So our final speaker this afternoon, Robert Howard, as you can see there, Advanced Commodities Global Consulting, the impact of natural gas depletion on oil production, due to the connections between the two. Welcome, over to you.
Thank you. It's good to be here as a speaker at last, and it's good to see such a big turnout. I promise I'm going to go very quickly through this. I know it's the end of the day, and you've had a long day, so I won't be too boring. Now, on the agenda, there's 12 points. There's obviously not enough time to go through all of them, so I'll be covering natural gas, liquids, the supply from the FSU, the South Pass North Dome gas field, gas injection into oil fields to keep up oil pressure, the effect of gas on tar sands production, and the oil and gas price ratio, which is all important for tar sands, heavy oil, US shale, and the price effects. And thank you very much for Simon, wherever he's sitting, for giving us that basic analysis of economics, microeconomics, very helpful when I get to that section, plus some of the choices we're going to have to make going forward. Now, as you can see from this, the top yellow line, basically the natural gas liquids, represents about 10% of our total liquids flow. So when we're told that we've got about 86 million barrels a day of total liquids production, we don't normally talk in terms of oil these days anymore. It's oil and natural gas. So that's a slight of hand that we use to get around the fact that oil production has effectively already peaked and declining. If you look at production from places like Saudi Arabia, their peak production of actual crude oil was sometime in the 70s and 80s. What you're seeing is the production made up in terms of natural gas liquids, and that's the slight of hand that we see at the moment. And there we have projections going all the way out to 2030, telling us how it's going to be ever onwards, and everything going to be looking bright and getting better every day. Now, myself, I'm quite skeptical as to whether that's actually true. I'm getting on to that, why I feel that is going on. And one of the reasons for that is the concentration of natural gas in just two areas. One is the Middle East and the other is the FSU. Now there's a lot of gas in the US, and I'm going to discuss that, but basically we are very much dependent on all that projection that we're seeing on supplies from the FSU and the Middle East. As you can see, in Europe we're quite aware of what the issues are with Russian supplies. It's not as bad as it once was, but it's still, Europe is extremely dependent on Russian natural gas supplies. I'll let you read that a little bit. It's a bit of a scary story. We're often told that the Russians are turning the tap off on us, and it would seem that from certain reports that have been coming through, and I'm sure we're all familiar with, that there may be a peaking in Russian gas supply. Even if there isn't a peak in the actual production, due to the extreme infrastructure issues that are plaguing Russia now, we may have constraints on the size of the tap that Chris was telling us about earlier. So basically, we put a lot of our hopes in Europe on Russian natural gas. I know that some of the talk going on these days is about, and it's not in this presentation, is about a massive increase in gas production in places, for example, in Turkmenistan, where their natural gas production has gone up about 50% over the last couple of years. Just to put that in perspective, Russian gas declines at about 5% eat up all of that gain in Turkmenistan. So Russia is a bit of a giant when it comes to natural gas production, and any vulnerabilities there, we will be feeling it. In terms of the Middle East, again, we have extreme geographic concentration in terms of the North and South Pass fields. And you can see that is actually, these two blobs are right here, the North Field and South Pass. With the declines potentially occurring in Russia, we're putting a lot of our eggs in the basket of receiving LNG from the Middle East, and there are some question marks around that. I'm not going to say I don't know the exact details, but there is a great deal of anecdotal evidence that you can see This is the official figures of reserves for Iran and Qatar. Just beyond Russia, you can see just the huge size of Russia. And below Iran and Qatar together, they are bigger. Now, Iran is quite important because it's also the world's fourth largest oil exporter, but it's also the second largest oil exporter out of OPEC. And Iran makes extensive use of natural gas for re-injection. You can see in Iran there's an almost permanent, and in much of the Middle East there's an almost permanent shortage of natural gas. So we're told that there's a huge, some of the biggest gas field in the world is the North Dome South Pass, and yet the Middle East is permanently in gas crisis. So I leave it to you to decide what the truth of the story is. You can see here the statistical analysis of gas fields. That extreme outlier at the end, that's the North Dome South Pass gas field we are supposed to believe is actually that size. And there are questions about whether that may actually be true. Now, off the record, I've talked to senior consultants and they have indicated that there may be significant issues with the size of that reserve analysis, and they can even tell you a story of how that particular number came about. But of course, all of this is off the record. For obvious reasons, it doesn't get discussed publicly. Now, gas is also used for injection. I know many of you here know about geology and you're fans of oil production, so you'll know how when you want to get oil out of an oil field, those gushes you see from like the 1850s where there's a derrick and the oil comes pouring out, that's under gas pressure, obviously, often. To get enhanced oil recovery, these days, places like Iran and many other places, for in terms of enhanced oil recovery, natural gas is injected into the ground. One of the other things that it helps do is increase the permeability of the oil through the oil shale. Now, as we have this, once we get gas depletion, we don't know when exactly that will be. There's some contention that it could be some way off. Then again, if the reserves are not as great as we expect, it might be sooner. Once you have that, gas doesn't tend to flow like oil. Oil's been described as something like treacle, whereas gas depletion is a bit more like a balloon popping. So when it goes, it tends to go very rapidly. In terms of tar sands production, tar sands is sold to us as oil sands where we use hydrogen from natural gas to produce the tar sands and turn them into oil. But another way to look at it is almost as a gas to liquids program, where the carbon from the tar is used to make the natural gas liquids. And that means that tar sands is extremely sensitive to natural gas production. This is a chart of the oil price, the ratio of the oil price to the gas price. Now the blue line is the energy price parity of oil and gas. At the blue line, oil and gas per unit of energy, calorie of energy, are exactly the same. You can see the extreme outlier we've had recently. We're at the 25 to 1. That meant that at 6 to 1 is parity. So natural gas on a per unit energy basis was almost 4 times cheaper than natural gas, which explains big rush to gas and why tar sands make so much sense. Except once you have gas depletion, we can expect this, it's already come down a bit, but you could expect this to come right down to this line, possibly lower. If that happens, you're going to lose production from things like tar sands, because why would you sell crude oil for $60 a barrel? Sorry, why would you sell natural gas for $60 a barrel once you converted it in tar sands when you could sell the gas itself for the equivalent of $100 a barrel? It affects the economics. It's very sensitive tar sands production in that sense.